We are at Cupp Computing here at Computex 2011. So what do you do?
Well, our focus is on a concept we call multi-mode computing. So we have for years tried to optimize the best ways to bring low power and x86 architecture into single devices. And this device here, for example, this is a standard netbook. This is our first rollout product, which we originally thought was just going to be a demo. And we realized it's actually a pretty cool product. Our technology brings these two domains together. Here you're going to see this is a punked ASUS EEPC, and if I just do keystroke, we move into a low power mode. This was not a software switch. This is actually, we've just gone from x86 architecture to an ARM-based system. In this case, it's an A8, working on a 3730 OMAP. So you basically take this device from being a 6-7 hour device to over 40-hour device.
40 hours?
40-hour laptop.
40-hour laptop?
Yeah. So,
so basically, do you transform any laptop to an Ampere laptop, or just some?
We're working, when we saw this, the potential of this separate module, I mean, we're working our way in to try and actually enable other people to make these devices. But when we saw the potential of this, we've looked at this, and we're going to explore this. This works in several laptops. Each way we do this is going to have to change depending on the laptop, because some laptops are a little bit different in the way they're configured. But the idea is this can go into basically any laptop, and there's no solderless as can be. So that was the concept. Take out the hard drive, you replace it with an SSD. You have a shared drive space now, so your applications are available on both sides. That's very unique. You can see that for years we've been working with patented technology. This is as seamless as is possible because it's basically instantaneous. If I'm on the high power side at the x86 and I'm working on a PowerPoint document or something, CAD file, and I have just 10 minutes left on my battery, and I turn off the x86, I have an hour or more left to make emails, to do what I need to do in the airport.
Nice, and it's even on the Mac.
We did this on the Mac. This is Apple is particularly finicky with messing with hardware, so this is probably not going to be a device that we'll have in this module. We did it actually originally, the first time we showed it all in public was in Barcelona, and we did this because it's very nice to see people's reaction when they walk by, especially if they're Mac users and they see an Android and they literally jump physically and they, that's wrong. So that was why we did it.
That's funny. That's awesome. So, this Android? Yeah. Could there be other? Ubuntu?
Sure, it should be Linux. You can see that device over there is using a Ubuntu.
Let's try it. That right there is Ubuntu on the ARM.
Yep. There's Ubuntu on ARM living on this system, and here we're back into a OS X. So
what is the switch you're using? Is that an added
well, in this case,
switch?
Yeah, this we did with on the key lock.
This is a key lock button. So you change the key lock to be instead of key lock, you be change OS.
Correct.
And the other part, the x86 just sleeps, hibernates.
You can shut it down.
Shut it down.
You can put it into hibernate is usually the most likely because it's very low power, but it's easy to bring it back up.
So it hibernates.
Yeah, it hibernates, and then you've got almost no current pull from that, but you have the ability to use this device for a long, long time. Still have access to your drive and whatever applications run on both sides. So it's very, very nice.
And right now is a Cortex A8.
Yes, I mean this will work. I mean the idea will work with anything. It could be any ARM, Qualcomm, could be MIPS, could be any other
Cortex
subsystem.
A9s, the faster ones, the dual cores.
Absolutely, of course.
Absolutely.
Yeah.
What do you mean absolutely?
Well, I mean there's definitely a lot of use cases for the better scenarios. So we're working our way towards that.
What do you need for the bigger chips to be there? What do you need?
No difference in our technology. We basically just need to do a new reference platform. So what we're doing here is we're exploring this idea. This was actually just part of our roadmap, but we see it. I mean, one of our sales guys said, this is actually a product. So we're taking this and we're going to explore it, and we have the sense that this could really be a good product. So we're putting it, encasing it. It could be an external thin client. It could be integrated directly in at the board level. There's lots of different implementations. The more success we have initially, the more fun we'll have with it. It's a really fun product to work with, and that's why one of the reasons we use the 3730 is it's very open, very hackable. You can play with it and do many different things. But you know, the concept just needs our technology to enable it. We can do it with anything.
But you're a for-profit company, right?
Pardon me?
You're a for-profit company.
Oh God, I hope so.
Coming
It's
out
been
of the
5 years of hard work. I hope we're for profit.
But you came out of the university, Kamal?
No,
university
we're the
project
very
or no?
definition of disruptive technology.
A company.
We were a group of people that came together some years ago with an idea for a device that was really bridging these two domains, and we explored that but discovered that it couldn't be done. And in that process we came up with the technology. Our core technology is patented. It's a bridge between these two domains that allows you to do the video switching and what have you. And the real-time interfacing. There's lots of application fun you can have with this. So we are now public and out there, and we're looking to excite people, basically, and get people into the idea. It's called scalable computing, multi-mode computing, where you really allow a user to cover the full spectrum of things that they need to do.